Hey everyone, welcome to the Electric Piano Tinkercad workshop, hosted by the IEEE UTD Tech Committee. I'm Victor Lopez. I'm going to be showing y'all how to make this workshop. So first of all, I want y'all to sign in with the QR code, or you can type in the link which is right below it. I'll give you all a couple minutes to do this. It shouldn't take too long. It's like, I don't know, 4 or 5 things to fill in, not too much. And the link is also going to get posted in the chat probably later on for those who could make it on time or join the stream later on. So if you don't sign in right now, it's not too big of a deal, just as long as you do it before the stream ends. So we're going to be building this workshop in Tinkercad. Most of y'all probably had to use this already since we're on an online format. But basically what Tinkercad is, it's an online simulator tool for 3D modeling, circuit design, and coding. There's a lot of free lessons plans, built-in circuits also, Arduino, sensors, motors, logic gates, and more. And it's just really nice, convenient. It's free also, which is the best part. So yeah, first you're gonna have to create a Tinkercad workshop, or a Tinkercad account, my bad. And how you do that is you go to tinkercad.com, click on the Join Now button in the top right corner, create your own personal account. You can use whatever email you want. And once you're signed in, you go to the left column, click on circuits, and create a new circuit, and then you're ready to go. So I'll give you all a minute or two to do that since it's quite a few steps, but the last few, I'll show you how to do it. So the basics of Arduino, what an Arduino is basically, it's a microcontroller, and it's kind of like a tiny credit card sized computer. The reason they're very good is because they're very versatile. They're powerful as well, and they're low price. And people who use these are typically hobbyists, makers, artists, students, a lot of electrical and computer engineers, because I don't know, we just can build a lot of things with it. And the parts we're going to be using today is our push buttons, resistors, and a piezo buzzer, as well as the Arduino. Y'all should also go check out our old workshops on our IEEE UTD YouTube account. There's a couple there. There's a Cyclone LED project, and we had a couple of workshops last semester also. One of them was a fire alarm project and an intro to Arduino workshop, which just showed you how to use a couple parts. So yeah, I highly recommend checking it out if you want to put some stuff on your resume. Projects are very good for your resume, especially when you're applying for internships or jobs. So the parts we're going to be using are the piezo buzzer, resistor, and a push button. So what a piezo buzzer is, it basically acts like a speaker, and it's an output device that generates sound. And how a piezo buzzer works is it has a voltage that passes through a piezoelectric material, and it causes a motion that is then converted into sound with diaphragms or resonators. And they operate really well in the 1 kilohertz to 5 kilohertz range. The other item we're going to be using is a push button. Push button is just basically like a normal button, but it has a variety of uses in Arduino projects. How a push button works is it completes the circuit when it's pushed down, because there's a metal spring that's between 2 wires, and it connects the 2 wires whenever it's pushed down. And then when it's not pressed, the string contracts and the wires aren't touching anymore, so the connection is lost. And in this workshop, we're going to be using multiple buttons to tell the buzzer what note to play. And I'm going to demonstrate now. And I want to thank you all for joining, and sign in if you haven't. So once you've created your account, you go right here to circuits, you click on it, then you create a new circuit. And the first 3 things, or first couple things we need are an Arduino and a breadboard. I would say get a large breadboard since we're going to have a lot of buttons. And the other couple parts we're going to need are 7 buttons. So just grab 7 of these and place them on your breadboard. We are also going to need a buzzer. So I'm going to go put that over here. And we will grab the resistors as we need to grab them. So first, what we're going to do is we're going to connect power and ground to the breadboard, and these columns here work vertically, and how it's oriented right now, I guess it's horizontal. So first we're going to hook up 5 volts to power, which is right here where the plus sign is, and we're going to make that red. After that, we're going to hook up ground where the minus sign is. We're going to make that black. After that, we're going to connect power to the other side of the breadboard. At the plus for power and minus sign for ground. So what we're going to do first is we're going to connect the negative end of the buzzer, which is the black circle, to ground. And we are going to connect the analog 0 pin all the way over to the positive terminal of the buzzer. And I'll make that purple. Now what we have to do is this leftmost push button, what we're going to do is we're going to hook it up to power because we need to power all of them, and how we're going to wire these buttons up isn't how you normally would. So after you've connected the leftmost button, the left terminal 1B pin to power, you're going to connect terminal 2B over to the next terminal 2B on the pin. And that's just so we only have to wire up one button instead of having to do 7 different ones. It just makes it a lot more convenient. And how we're going to do this, connect power to the rest of the buttons are using resistors. So the first one, or the second push button we're going to wire, we're going to power it with a 220 ohm resistor. And the reason we're going to wire up these push buttons with different ohmed resistors is because we want a different voltage going through each one of them for our code later on, which you'll understand once I start writing the code. But we are going to use different valued resistors for each of these push buttons. How am I going to do this? Okay, so I'll wire this resistor right there. And the next resistor is going to be 1 kilo ohm, so you can leave it as it is. And I'm going to wire this resistor over to terminal 1B. And all of these are hooked up together, so terminal 1B can also be right here. So you don't have to connect it directly to terminal 1B. It just has to be in this same row. Then after this, we're going to connect the other terminal 2B to the next terminal 2B for the next switch. And we're going to keep doing that for each button until this last one. So the next resistor we're going to hook up for the middle button is going to be 4.7 kilo ohms. The next resistor is going to be 10 kilo ohms. And you're going to hook one of the pins of the resistor to power. So the power goes through the resistor and then all the way to terminal 1B of that button. After the 10 kilo ohm resistor, or this is the 10 kilo ohm resistor, my bad. So after the 10 kilo ohm resistor, we're going to use a 1 mega ohm resistor. So we're going to change the value to 1 mega ohm. Or did I miss one? 220, 1K, 4.7. I think I got them all. And yeah, so this one has to go to ground actually. So this last resistor goes to ground because the power goes through all of them and then it has to return to ground somehow. So this last resistor will be 10 kilo ohms. So after all of that is done, that's just the wiring, all the wiring we have to do. I'll give you all a minute since I went a little fast with it. And a few of you are probably new with Tinkercad. So basically how this project works is the buttons we push down are going to play a specified note, which will be done in the coding. And based on what button is pushed down, this buzzer is going to emit the specific note. And how the buzzer knows what notes to play will be coded on the Arduino. And how we are going to code which note is going to be played is based on the voltage that is passing through each button. So this first one, it's going to have, if you output in the serial monitor what's going through this button, it's going to say 1023, and then each other one is going to have a different voltage going through it. So it's going to say a different amount whenever you do an analog read on it, because of these resistors. So the higher the resistor, the smaller the value is going to be. And that's pretty much it. So I'm going ahead and going to start writing the code. So we're not going to be writing in blocks. We're going to be doing it in text. And the first couple of things I'm going to do is I'm going to, oh, wait, there's one last wire we have to do. We have to wire this last button to analog 1 pin. Okay, so the resistor values, they're 220 ohms. So I'm gonna go from left to right. So the leftmost button does not have a resistor. The second one has a resistor of 220 ohms. Then the next one over is going to have 1 kilo. The last one, or the next one over, it's going to be 4.7 kilo ohms. Then the one after that is going to be 10. And I'll go over them many times. So after the 10 kilo ohm resistor, which is after the 4.7, is going to be a 1 mega ohm resistor, and the last one is going to be a 10 kilo ohm resistor. So the resistors we are using are 220 ohms, and then 1 kilo ohm, 4.7 kiloohms, 10 kiloohms, 1 mega ohm, and another 10 kilo ohm resistor. And I'll wait here. If y'all need me to go through them again, just put it in the chat and I'll do it. So just one last time. First resistor is going to be 220 ohms. The next one over is going to be 1 kilo ohm. The next one over is going to be 4.7 kilo ohms. Next one is 10 kilo ohms. Next one is 1 mega ohm. And the very last one is 10 kilo ohms. So now I'm going to start the code. And first thing I'm going to write are the pins for each resistor. So these are going to be constant integers because the pins are not going to change. So for the button pin, it is analog pin 1, which is just A1. Thank you to whoever said I make the wires look nice. So the next thing I'm going to write is the pin for the buzzer, which is also a constant integer. And that's just at analog pin 1. And the other two variables we're going to use are going to be an integer array. And how you write an array is just you write the data type, which is an integer, int, and notes, and you do square brackets, one open and one closed. And this will hold the value of our notes. So the first note is going to have a frequency of 262 hertz. The next one will be 294. The next one will be 330, 349, 392, 440, and 494. And after each of your statements, you have to end with a semicolon. Otherwise, your code won't run properly, which is not fun because you run around looking for the bug in your problem or in your code, and then you just realize it's a semicolon. And the last variable we're going to use is an integer called keyval. And here in the setup, all we have to do is we have to write the pin mode of the buzzer, which is the buzzer pin, to be an output. And all that means it's just going to be outputting some form of signal or sound or something. With a LED, it's an output because it's outputting light. With the buzzer, it is outputting a sound. And the loop, you just delete all the pre-written code for you, since we're starting from scratch. And the first thing we're going to do is we're going to read what the value is across each button. And how we do that is we write keyval is equal to analog read button pin. And that's just reading which button is getting pushed down It's just reading what button's getting pushed down based on the value that's, or based on the voltage that's going through it. And now we are going to write what note the buzzer is going to play. And we're going to be using that with if and else if statements. So if the key value is equal to 1023, then that note it's going to play is going to be D. Or it's going to be playing the note C, my bad. Which is the first note. So the notes go from C, D, E, F, G, A, B. For those of you who have played an instrument or know how to read music. And that's it. So the next note we're going to play is D, and that is if the key value is between 990 and 1010. So if the key value is greater than 990 and then less than or equal to 1010, we're going to tell the buzzer to play the note D, which is the second index of our notes. And in an array, your indexes start from 0 all the way up to -1, however many items you have. So we have 7 items in our array. So how it counts is actually 0, index 1, index 2, index 3, index 4, index 5, index 6. So counting starts from 0, kind of weird. So yeah, we're going to tell it to play D, which is notes 1 in the square brackets. After that, we keep doing this process for each note, and if the key value is in between 960 and less than 980, then the note is going to play E, which is the 330 frequency one. Oh, my bad. And we tell the buzzer what to play using the tone function, which is a built-in function on Arduino. And we can make this process quicker if we just copy the else if statement and keep on pasting it. So after 960, we're going to change the value to greater than or equal to 900 to less than or equal to 945. The next one will be 650 or greater than or equal to 650 to less than or equal to 710. The next one will be 500 or greater than 500 and less than or equal to 550. And we have to change the notes for each one of these. So for the between 650 and 710 will be note 3. For the 500 and 551, it'll be note 4. The next one, the values will have to be between I think I missed one, or did I? 0, 1, 2, 3, 4. $990, $910, $960, $980, $900. Oh, I missed one. So here, this one right here is supposed to be the 650 and 710 one. There was supposed to be a 900 and 945 one before it. So we have to scoot each one of these down one. So after the 900, 945 one, it'll be 650 and 710. And after the 650 and 710 one, it'll have to be between 500 and 550. There we go. So the last note that we'll play is the 494 hertz one, and that will be between a key value of 5 and 10, and that will be playing note 6. And the last thing we're going to do is write an else statement saying that if no button is being pushed, then we don't want the buzzer to be playing. So how we do that is we write no tone, and then we put the buzzer pin, which turns it off. And that's all the code for it. I'll leave this code up before we do anything, because I wrote the code a little quickly. But basically how the code works is we said what the pins were. So that's the pin for the button. This is the pin for the buzzer. This array holds the notes. This key val tells us which button is pressed. The pin mode buzzer pin statement says the buzzer is an output item. The analog read line says reads the voltage from the buttons. And you don't have to write the comments that I'm doing. I'm just doing this so y'all understand what each line does. So this if statement tells us that the first button is getting pushed down. Which is this one right here, the leftmost one. And what that does, it tells the buzzer to play the first note. Which is C. Tells us the second statement, else if statement tells us the second button's getting pushed. And that keeps going for each one of them. And this next statement just tells the buzzer to play a D, which is the second note. And that keeps going on for until we hit the end of the array, which is the last note, I believe, is B. And this last statement tells the buzzer to play nothing. So I'm going to demo this for y'all now. How did you demo it is you start the simulation. Oh. Button pin and buzzer pin. Oh, my bad. I forgot to put an equal sign. My bad. So I tried to define my constants, but I didn't. My bad. So between button pin and A1, you put an equal sign, and between buzzer pin and A0, you have to put an equal sign. And I am just full of bugs today. Okay, so it should work now. I put note instead of notes. There we go. So I'm gonna warn y'all before I push any buttons down, because I will admit it is really loud and it might hurt your ears if you have very sensitive ears. So I'll give y'all a second to lower your volume before I push any buttons. Okay, so I'm going to push the button in 3, 2, 1. And why is it not working? Man, I am just really off today, aren't I? So the buzzer pin is $A0. The key val, tone buzzer pin, analog read button pin. Oh, there we go. Apologies. So I push this button down and it plays a note. That's strange. It's only playing one note. I apologize for it not working how it's supposed to. I'm trying to see where I am going wrong. I'm going to switch circuits to see where I'm going wrong. Did I forget a resistor? Is it one of my read button wires? You are right, actually. I should have a wire right there. Regardless, I noticed another flaw. The second resistor has to be 560 ohms. So I was also off on my resistors. So this one's 560, so it goes 220, 560. One kilo ohm. 4.7 kilo ohms. 10 kilo ohms. The second resistor needs to be moved over one. I can't necessarily do that. And the resistor's already connected because I connected it by a wire. And then I have to wire terminal 2 right there to ground. Then the 10 mega ohm resistor goes here. This should be correct. I'll be playing my notes now. There we go. And of course, my last one doesn't work.
Victor, is it 560 ohms or 560 kilo ohms?
It's just 560 ohms.
Okay.
So it goes in increasing order: 220 ohms, 560 ohms, 1 kilo ohm, 4.7 ohms, 10 kilo ohms. That should be 1 mega ohm, not 10. 1 mega ohm, and then 10 kilo ohms is the last one. So what I had wrong was I didn't connect these two 2B terminals. So I put a wire between them, and then I had to shift all the resistors over one switch. So the 1 kilo ohm one, which was right here where the 561 is, had to be moved to the next one. The 4.7 kilo ohm was moved over one, and it kept on moving over. So the 560 on one is supposed to be with the third button right here. And that should make the circuit work now. And this is just one octave. If you wanted to add in, let's say, half steps like between C and D is C sharp, or D and E is D sharp, you would have to add more buttons and then add a variety of other resistors that would read in between a range of values. So in theory, you could make a full set piano set with an Arduino and buttons and resistors. But for simplicity's sake, I just decided to do one octave C, D, E, F, G, A, B, which is one octave of notes. I'm not very musically inclined on a piano, but I can play Twinkle Twinkle Little Star for y'all.
Victor, we're getting no audio.
Oh, dang, that's kind of awkward. Oh well, but oh well. Yeah. So basically, if you start the simulation on your own and you push the buttons, it should be making sound. This should be the lowest note, and then the rightmost button should be the highest note. So yeah, that's pretty much it for this workshop. Not much else to it. Just wiring a bunch of buttons to power with resistors and connecting the terminals between each other. Wiring one button up and then wiring a buzzer up and connecting powers. Not a lot to it. The code is right here. And that is pretty much it. So I would like to thank y'all for joining me. And if y'all have any questions after we're done with this stream, like for example, later on, you thought of something you want to ask, you can DM me in Discord. I'm Victor Lopez in the Discord. If you have any questions right now, you can drop them in the chat and I can try to answer them, or Sarvan or Neil can try to answer them. But that's pretty much it. So if y'all want the sign-in link, it is right here. I'll present that for y'all. It's at https ://forums.gle/ the rest. Y'all can read it. Or you could scan the QR code. It'll take you to the same place. So one of y'all had a question about the third resistor. So the third resistor is actually 1 kilo ohm. I had to shift them over because I forgot to include the 560 ohm one. So the order was actually 220 ohms, 560 ohms, 1 kilo ohm, 4.7 kilo ohms, 10 kilo ohms, 1 mega ohm, and then the last um, terminal 2B of the last button had to be wired to ground using 10 kilo ohms. So yeah. And yes, the values of the notes in the array, and the notes array is actually the frequencies for each of the values, or for the notes. So 262 hertz is C, 294 is D, 330 hertz is E, and it keeps going up, 349 F, 392 G, 440 is A, 494 is B. And then you could actually find these in a pitches file. Pitches.h is what the file is called. You could Google pitches.h Arduino. And you can find it here in GitHub. And right here, it'll tell you what node is what. So if we scroll down, we could see all the nodes we were talking about, 262C, 294D. It tells you what each and every node is, and it's just the frequency. I'm going to pull up the sign-up sheet one more time. So before y'all leave, I'd please ask y'all to sign in. Gives us an idea of what workshops y'all are interested in, and just see how interested y'all are in these workshops. So I want to thank y'all one last time for showing up to this workshop. It really means a lot, and we're going to have a lot more of these throughout the semester.